So, welcome to this question here. Now, this question is very straightforward, but at the same time, it's a fundamental concept that if you don't know it, then it's going to make this question very tricky. So, my key to this question is to remember that groups are the vertical columns. So, groups run vertically on the periodic table, and then periods are the horizontal rows. Now, they're so-called periods because the word period in English language means a cycle. So, the periodic table starts at element number one, which of course is hydrogen, and then goes all the way over to helium, element number two. And then you can think of it like a circle that goes right behind the periodic table, comes back around and comes on to the next row, and then continues across row two, and then cycles around the back of the periodic table again into row three. So there's where the concept of period or cycle comes from for the rows. So the columns are the vertical, they run vertically, and the rows of the periods run horizontally. Now, if we come back to the question here, we're trying to identify an element. Now, it's not the element meh. We're not looking for this element. Unfortunately, that's not an option when you take IB chemistry. So we can't just be indifferent about this subject. We have to actually pay attention here. So what we're given in the question is we're given an electron configuration. So the electron configuration of the element we're looking for is 1s2, 2s2, 2p6, 3s2, 3p2. Now notice there are no commas between the numbers. It's tempting to do that, but that's actually incorrect to do. So don't put any commas between the numbers. And also we have three aspects to each number that we have here. So I'm just going to tell you what each one of these things represents. The large number in the front tells you the row or period. So if you have number one there, we're talking about row one or period one in the periodic table. If you're up to number two, then you're up to energy level 2 or row 2. And then if you're up to number 3, then you're up to row 3, period 3, or energy level 3 of the element on the periodic table. So this relates really nicely back to question 6 before, because in the previous question we were talking about the origin of these energy levels. So this question 7 is effectively building on that theory, and this is where we got this idea of then distributing the electrons within those different energy levels. So the next thing that we look at is the letter. So we have S or P here. Now S is for the orbital type. So this is an S orbital. And it's simply the shape of the orbital that the electron can occupy. Now if you're ever asked to draw an S orbital on an IB exam, it's one of the easiest marks you could possibly pick up. You just simply draw a little sphere or a circle. The other orbital type or shape that we're considering here is a p orbital. And a p orbital is not that difficult to draw either. It's a bit like those old school dumbbells, and that's a p orbital. You get your mark for drawing that. So we now know what the large numbers represent and the letters represent. The superscripts, or the numbers on the top, represent the number of electrons in the orbital. So in this 3p orbital, at energy level 3, in this p orbital, we have 2 electrons. At energy level 1, in this s orbital, we have 2 electrons. The other thing we can say here, I'm just going to try and unpack this question as much as possible. I could have answered it already, but I just want to teach you guys a little bit extra. The more understanding you have, the more confidence you have answering these questions. So what else can we say here? So if your final orbital that is filled is a p orbital, so p orbital is the final orbital which is filled or occupied, then you can say this is going to be a p block element. Now, the p block of the periodic table is this block that I've just identified right here, excluding helium. This is what's known as the p block, because all of these elements in the p block, or the right-hand side of the periodic table, will have a p orbital as their final orbital which is filled. You also have the s block on the far left, and then the d block elements, or the transition metals, which are in the center of the periodic table, which you focus on a lot more if you take higher level. Okay, so we've unpacked quite a lot of information from this simple electron configuration. Now we're trying to identify which element this is, and I could have said this at the beginning and saved us all this time, but you can very quickly identify what element this is by simply adding up the total number of electrons here. So we have 2, 4, 10, plus another 2, plus another 4, so 14 electrons. Now an element with 14 electrons, I'll just scroll down the page a bit to get some space. So an element with 14 electrons, Now, they remember we talked about a question before which talked about the significance of atomic number and mass number, and we said before that atomic number told you the number of electrons, and we also said that atomic number couldn't change. So if you have 14 electrons, you must have 14 protons for a neutral atom, and they're talking about an atom here with this electron configuration. So with 14 protons, you quickly identify that the element with atomic number 14 is silicon. So we very quickly identified that it's silicon, and all you have to do then is determine what its group number is and what its period number is. So silicon is group 14. It's there for you to see, at the top of your periodic table, group 14. And then the row number is going to be row number 3, because don't forget to count hydrogen and helium as row number 1, then row number 2, and silicon is down here in row number 3. So the answer there is D. It's as straightforward as that, group 14, period 3.